f2018. We're doing some more classic beginning programming stuff with algorithms. And so we're going to do sorting and bubble sort is in a video that's uploading now. Let's do linear search and binary search. All right, so I will take some notes and a new R script just to keep the Google Doc from getting too crazy crazy long. And we're going to save this as linear search. All right, so this is a problem that we want to solve. Notes on search. So given a list of numbers, we're looking for one. So our input data would be some list, potentially sorted, potentially not sorted, and search for some number. Let's say that we're going to search for the number 4. Okay, so we have this list, and then we have some number we're looking for, desired output, yes or no, and where in the list is the number. So keep in mind, there could be thousands or millions of numbers in the list. Right, with a list this short, we just look and say 4 is there. But what do we do if there's potentially quite a bit more? Okay, so there's a couple different algorithms for this. The first one we'll do is called linear search, and I'll put that in parentheses. But the easier to remember is look at everything in order. All right, so I'm going to take my my list here. This is my input, and also is 4 in the list. And the way that we're going to do this, so I'll kind of keep track here. So basically, linear search is just going to be, I look at the first number. Is this a 4? No. Is this a 4? No. Is this a 4? Yes. That's it. And if I want to draw a picture of that, then I could do this. Maybe I'll put a dot underneath the one that I'm currently looking at, or maybe a caret. So if you want a visual of how this works, first we look at the 5, no, then we look at the 2, no, then we look at the 4, yes. All right, so this is actually much simpler than the sorting algorithms that we did. Algorithm looks like this. Is the first number the one we want? Let's say looking for number x. So is first number in the list equal to x? Is second number in the list equal to x? And so on, all the way through. And let me put this more in pseudocode. So let's say my input is a list called numbers and a variable x. Desired output, wherein numbers is x, or not present. Okay, so I'll say for I equal to 1 up to length of numbers, right? So however many numbers there are, then I would say if numbers bracket I, the ith one, equals x, then maybe return I. So then we would know where in the list it was. If we get done with the for loop, finish for loop without returning, maybe return -1 to mean it's not there. Okay, so this would be more of an algorithm description for somebody who has done some programming like we have. It looks closer to code. All right, let's go ahead and put this into actual code now. I'm going to make a function called linear search. This is a function. I'm going to take some numbers and a variable, and linear search function. So numbers should be a list of numbers. X should be a number to look for. Okay, and then what should we return? We'll say that we're going to return just what I set up there. Return the index of the first occurrence of x in numbers, or -1 if not present. Right now I'm just going to return 0 just to get started, and let's give ourselves a list of numbers, and I'll take this one here. We'll do this same kind of thing. A tip for you, if we're in RStudio, you can do Control-Enter on Windows or Command-Enter on Mac. So I'm going to do Command-Enter. I'm on a Mac, and that runs the current line that I'm on. That's the same as clicking the Run button here. That runs just the current line. All right, so now I have nums is an unsorted list of numbers, and then I'm going to print the result. Let's say result is linear search nums, and which one I'm going to look for. Let's just say I'm going to look for 500. Okay, if I try to do this right now, what do you think is going to happen? It will maybe be 0. But actually I haven't sourced this file, so it doesn't even know about the linear search function. So I ran that line. It doesn't know about the linear search function. I can run the whole file to load the linear search, or I can just put my cursor at the top of the linear search function and click the run, and that just loads the linear search function. So it just loaded that, and now I can run this and run the next line, and I get my 0. Okay, now I'm going to take my pseudocode here. Let's see, I'll put it like this, and I'm going to put that in, and then convert this into real code. All right, so for I in, so 1 up to the length of the numbers, 1 to length of numbers. And that's stuff that's part of the for loop. So if numbers bracket I equal x, return I. So that's exactly just like my comments were. Okay, and then if I happen to get here, then I'll return -1. Rather than 0, that's what I'm supposed to do. Okay, and so the way this works, we go through. If we ever hit the return, the function is done. That's the way return works. If we get here, then it must be the case that we didn't find x in the rest of the list. I'm going to go ahead and source this to run it all. And it ran, so the second time it ran, it did find the number 500, so I should be able to look at the nums. So the first time I ran, I got -1, which means probably the 500's not there, if my code's correct. Let's look at nums to see if there's a 500, and it says 18, so it should be in position 18. There it is. And we could also look at nums bracket 18. If we run this, it's normally going to be a -1 because we have numbers from 1 to 1,000, 100 of those, and we're looking for one. So this is like a tenth of the possible numbers are going to be in there because we go 1 up to 1,000, but we only have 100 of them. So we sort of have a 1/10 chance that we're going to have 500 in there. All right, this is the code for linear search. It's super awesome and exciting. Yippee-doo. Right. The end.